Before the first encounters on the Eastern Front, German planners believed they had already solved the problem of armored warfare. Their doctrine emphasized combined arms, crew training, command flexibility, and precise gunnery. Tanks were expected to fight other tanks using superior optics, coordination, and tactical maneuver. Armor thickness mattered, but only to a point. Mobility and firepower were considered decisive. From this perspective, the Soviet approach to tank design appeared crude, inefficient, and technologically unsophisticated. This is the context in which the T-34 was initially dismissed. German intelligence assessments before 1941 underestimated Soviet industrial capability and overestimated the sophistication gap between German and Soviet engineering. Reports described Soviet tanks as numerous but mechanically unreliable, poorly finished, and crewed by inadequately trained soldiers. German doctrine assumed that even if Soviet tanks were thickly armored, they could be defeated through superior tactics and anti-tank gunnery. The idea that armor geometry itself could fundamentally alter battlefield outcomes was not seriously considered. Sloped armor, in particular, was not viewed as revolutionary. German engineers were aware that angled plates could increase effective thickness and deflect incoming rounds, but they saw this as a marginal improvement rather than a decisive one. German tank design emphasized vertical armor plates that were easier to manufacture, easier to repair, and simpler to integrate with existing hull structures. Angling armor complicated internal layouts, reduced usable space, and created manufacturing challenges. In a system optimized for precision engineering and tight tolerances, sloped armor looked inefficient. There was also doctrinal bias. German anti-tank doctrine relied on defeating enemy armor through gun performance rather than survivability contests. Tanks were not expected to absorb hits. They were expected to maneuver, flank, and destroy the enemy first. This mindset reduced the perceived value of heavy or cleverly shaped armor. Protection was important, but it was secondary to battlefield control. When intelligence reports mentioned Soviet tanks with thicker frontal armor, German planners assumed that penetration would still be achievable at combat ranges with existing weapons. Calculations focused on nominal armor thickness, not effective thickness created by slope. This distinction mattered enormously, but it was not emphasized in pre-war German assessments. Armor was measured in millimeters, not angles. There was also a cultural dimension. German armored doctrine had evolved through practical experience in Poland, France, and the early campaigns of the war. In these theaters, German tanks performed effectively against opponents whose armor was either thin or poorly employed. This reinforced confidence in existing design philosophy. Success bred assumption. If current tanks were winning battles, radical redesign seemed unnecessary. The Soviet Union, meanwhile, approached the problem from a different angle. Expecting to fight numerically superior and technologically advanced opponents, Soviet designers prioritized survivability, simplicity, and mass production. The T-34 was not built to win elegant duels. It was built to survive long enough to kill and to be produced in overwhelming numbers, even under catastrophic conditions. Sloped armor was central to this philosophy, not as an afterthought, but as a defining feature. German observers initially misread this philosophy as incompetence. The T-34's rough welds, cramped interior, and basic optics were interpreted as evidence of inferiority. German crews encountering early models often noted poor visibility and awkward ergonomics. These observations reinforced the belief that Soviet tanks were technically backward. What they missed was that these compromises were deliberate trade-offs made in favor of protection and production speed. Early German encounters with the T-34 during Operation Barbarossa shocked frontline units, but disbelief persisted at higher levels. Reports of shells bouncing off Soviet armor were often attributed to poor shot placement, defective ammunition, or isolated anomalies. Commanders assumed that existing anti-tank guns would be sufficient once proper tactics were applied. The idea that the tank itself represented a systemic challenge to German doctrine was slow to take hold. Part of the delay came from institutional inertia. Admitting that a supposedly inferior enemy had fielded a fundamentally superior design carried uncomfortable implications. It suggested that German pre-war assumptions were flawed, that intelligence assessments were incomplete, and that doctrine needed revision in the middle of a war. These were not conclusions reached easily or quickly. The dismissal of the T-34's sloped armor was therefore not ignorance in the simple sense. It was a failure of perspective. German planners evaluated the tank using criteria optimized for their own design culture rather than for battlefield reality. They saw what the T-34 lacked by German standards, not what it achieved by Soviet priorities. Sloped armor challenged more than gun penetration tables. It challenged the idea that technological sophistication had to look refined. The T-34 demonstrated that geometry could substitute for mass, that survivability could be engineered through shape rather than thickness alone, and that a tank could dominate the battlefield without fitting traditional expectations of quality. At the start of the war, German doctrine did not account for this. It assumed that armor protection increased linearly with thickness and that superior guns would always restore balance. The T-34 violated both assumptions. Its armor was not just thick, it was deceptive. It forced German gunners to relearn engagement distances, aiming points, and penetration probabilities under combat stress. The initial dismissal of the design delayed appropriate responses. Anti-tank units were sent forward with weapons that struggled to penetrate the T-34 frontally. Tank crews entered engagements expecting familiar outcomes and instead encountered resistance they could not explain immediately. Tactical confidence eroded before doctrinal understanding caught up. In hindsight, the dismissal of the T-34's sloped armor was one of the most consequential misjudgments of the war. It was not merely about underestimating an enemy vehicle, it was about underestimating a design philosophy that prioritized battlefield survival and production resilience over refinement. The consequences of that misjudgment would ripple through German armored doctrine for the rest of the war. Combat would soon force a reckoning, not through theory or reports, but through repeated, costly encounters where shells failed, assumptions broke, and German doctrine was exposed as incomplete. When German units encountered the T-34 in sustained combat, the problem revealed itself not as a technical curiosity, but as a battlefield reality that refused to conform to expectation. The issue was not that German weapons never penetrated the tank. It was that penetration became conditional, unreliable, and highly sensitive to range, angle, and stress. That uncertainty alone was enough to destabilize doctrine built on predictability. Sloped armor altered the engagement in three interconnected ways. It increased effective thickness, it reduced the probability of penetration through deflection, and it punished small errors in shot placement. None of these effects were new in isolation. Their combination at scale was. A vertical armor plate presents a fixed thickness to an incoming round. Its defeat depends primarily on gun caliber, projectile velocity, and distance. A sloped plate changes that relationship. The same nominal thickness now presents a longer path through armor, forcing the projectile to expend more energy. At the same time, the angle increases the likelihood that the round will ricochet rather than penetrate, especially at longer ranges or suboptimal impact angles. The result is not immunity, but inconsistency. Some shots penetrate, others fail, under conditions that are difficult to predict in combat. This mattered enormously for German gunners. German anti-tank doctrine relied on rapid identification, precise ranging, and confident engagement. Crews were trained to know when their weapons would penetrate and when they would not. Against the T-34, that certainty vanished. Engagements that should have resulted in kills produced bounced rounds instead. Crews were forced to close distance under fire or attempt flanking maneuvers that were not always possible in fluid engagements. The T-34's frontal armor, sloped aggressively, often rendered early war German anti-tank guns ineffective beyond short ranges. Even when penetration was theoretically possible, battlefield conditions rarely matched ideal parameters. Mud, smoke, movement, and stress degraded accuracy. Each failed shot extended the exposure window of German gunners, increasing casualties and reducing tempo. This disruption of tempo was critical. German armored doctrine emphasized initiative: strike first, move fast, exploit success. The T-34 slowed that cycle. German units could no longer assume that first contact would lead to immediate destruction of enemy armor. Instead, engagements became prolonged, uncertain, and costly. The tank absorbed punishment long enough to return fire, reposition, or allow supporting units to intervene. The sloped armor also altered engagement geometry. Shots that might have penetrated vertical armor at oblique angles now glanced off. Weak points existed, but they were smaller and harder to hit under combat conditions. German gunners had to aim more carefully, often under fire, while Soviet crews could rely on the tank's shape to forgive minor positioning errors. At the unit level, this translated into increased losses. Anti-tank crews exposed themselves longer. Tank crews were forced into closer engagements. Infantry support became more dangerous. Each tactical adaptation carried risk. The T-34 did not win every fight, but it forced German units to pay more for each success. Another effect was psychological. Repeated experiences of shells bouncing off armor eroded confidence in weapons and training. German soldiers trusted their equipment. When that trust was undermined, hesitation followed. Crews double-checked ranges, waited for better angles, or deferred engagements. In armored warfare, hesitation is lethal. The T-34 imposed hesitation through physics rather than fear. Importantly, the design worked even when other aspects of the tank were imperfect. Early T-34s had poor optics, limited radios, and cramped interiors. Soviet crew coordination was often inferior to German standards. Yet the tank's survivability compensated for these shortcomings. It allowed crews to survive mistakes, to remain in the fight long enough for numbers to matter. Survivability amplified mass. The battlefield effect was cumulative. Individual T-34s could be destroyed, but doing so required time, coordination, and risk. When dozens or hundreds were present, these costs multiplied. German units found themselves expending disproportionate resources to achieve limited results. Ammunition consumption increased, casualties mounted, momentum slowed. Sloped armor also interacted with mobility. The T-34's wide tracks and powerful engine allowed it to maneuver in terrain that restricted German vehicles. This meant that flanking maneuvers, the traditional solution to tough frontal armor, were not always available. The tank could appear in unexpected positions, forcing frontal engagements where German weapons were least effective. At longer ranges, German guns struggled. At shorter ranges, German units exposed themselves. This forced a tactical dilemma with no clean solution. Either accept higher risk or cede ground. Over time, this dilemma reshaped battlefield behavior. German units became more cautious. Soviet units pressed more aggressively, knowing their tanks could absorb punishment. The sloped armor's impact extended beyond tank versus tank combat. Anti-tank guns positioned to cover likely approaches found their engagement envelopes reduced. Infantry units equipped with light anti-tank weapons discovered that frontal shots were ineffective. Combined arms coordination became more difficult when the primary anti-armor tools underperformed. This did not mean the T-34 was invincible. German forces adapted. New guns were introduced. Tactical procedures evolved, but adaptation took time, and time favored the Soviets. Every month, the T-34 dominated at the tactical level, allowed the Red Army to expand production, train crews, and integrate lessons. German responses were reactive and constrained by industrial and logistical limits. The most important point is this: sloped armor did not merely increase protection, it changed the cost structure of combat. It made every German engagement more expensive in time, ammunition, and lives. That shift mattered more than any single penetration statistic. German doctrine had assumed that superior gunnery would always restore balance. The T-34 proved that survivability could be engineered in a way that disrupted that assumption. Armor geometry became a force multiplier, turning average firepower into a battlefield advantage through resilience rather than lethality. By the time German planners fully understood what was happening, the effect was already embedded in combat experience. Reports no longer spoke of anomalies, they spoke of patterns. Sloped armor was not a trick, it was a systemic advantage. Combat had delivered its verdict. The design that had been dismissed as crude was doing exactly what it was meant to do: keep tanks alive long enough for numbers, pressure, and momentum to decide battles. The cumulative battlefield effects of the T-34 did not merely complicate individual engagements. They exposed a deeper vulnerability in German armored doctrine, one that could not be patched by better gunnery or tighter formations alone. As encounters multiplied, German doctrine began to fail, not because it was poorly designed, but because it had been optimized for a battlefield that no longer existed. German armored warfare relied on predictability. Tanks were expected to identify threats quickly, engage at known effective ranges, and destroy enemy armor before it could respond. This model assumed that armor protection scaled linearly and that superior optics and crew training would consistently translate into first-shot kills. The T-34 disrupted every step of that chain. In practice, German units found themselves fighting longer, messier engagements. First contact no longer guaranteed dominance. Shots that should have disabled enemy tanks failed often enough to matter. Each failure forced crews to adapt on the fly, closing distance, changing angles, coordinating with infantry or artillery under pressure. These adaptations slowed tempo and increased exposure. The doctrine's emphasis on speed and decisive action became harder to sustain. The most immediate doctrinal failure appeared in anti-tank defense. German defensive layouts assumed that anti-tank guns could stop armored thrusts at predictable distances. With sloped armor reducing penetration probabilities, those distances shrank. Guns had to be positioned closer to likely avenues of approach, increasing vulnerability to artillery and infantry. The layered defenses that once provided depth now offered diminishing returns. Tank versus tank doctrine fared no better. German tanks were designed to fight at range, exploiting optics and accuracy. Against the T-34, this advantage eroded. Engagements drifted into closer distances where survivability and numbers mattered more than precision. German crews were trained for these situations, but training could not negate physics. Close-range fighting increased losses and reduced operational endurance. Command decisions became more conservative as uncertainty grew. German commanders hesitated to commit tanks aggressively when they could no longer be confident of rapid success. This caution was rational, but it undermined offensive momentum. Opportunities that might once have been seized decisively were approached incrementally or deferred altogether. The T-34 did not need to outmaneuver German tanks to blunt attacks. It needed only to survive long enough to complicate decisions. Attempts to compensate doctrinally revealed further weaknesses. German units increasingly emphasized flanking maneuvers to avoid frontal engagements. In theory, this restored advantage. In practice, terrain, Soviet defenses, and the T-34's mobility often denied clean flanks. Wide tracks and strong engines allowed Soviet tanks to operate in mud and snow that restricted German vehicles, limiting maneuver options. What doctrine prescribed, terrain and enemy design often denied. Infantry cooperation became more critical and more dangerous. German infantry were asked to close with T-34s to employ close-range anti-tank weapons or direct fire. This exposed infantry to machine gun fire and artillery. Casualties rose, coordination demands increased. Combined arms operations grew more complex just as the German army faced mounting manpower shortages. German doctrine also struggled with scale. It could adapt tactically to a few T-34s. It could not adapt easily to hundreds. The tank's design was inseparable from Soviet production capacity. Sloped armor allowed the T-34 to achieve survivability without extreme weight or complexity, enabling mass production. German doctrine was not designed to face armored forces that could absorb losses and keep coming. As engagements multiplied, German after-action reports began to reflect frustration. Commanders noted the need for heavier guns, improved ammunition, and revised tactics. These observations were accurate, but they addressed symptoms rather than causes. The deeper issue was that German doctrine assumed qualitative superiority could offset quantitative disparity indefinitely. The T-34 proved that assumption false when survivability and numbers combined. The psychological impact on doctrine was subtle but corrosive. German officers had confidence in their methods because those methods had worked repeatedly. When they stopped working reliably, doubt crept in. Doctrine relies on shared expectations. When those expectations are violated often enough, cohesion suffers. Units still fought effectively, but confidence in outcomes diminished. This doctrinal erosion affected planning at higher levels. Armored operations became more cautious, more dependent on preparation and support. This increased logistical demands and slowed operational tempo. In a war where time increasingly favored the Soviet Union, slowing down was itself a form of defeat. Efforts to revise doctrine mid-war faced structural limits. Training programs could not be overhauled quickly. Equipment upgrades lagged behind battlefield needs. New tactics required time to disseminate and practice, time German forces no longer had. Meanwhile, the Red Army integrated lessons faster, reinforcing the T-34's advantages through improved coordination and numbers. Perhaps the most damaging effect was the mismatch between doctrine and replacement forces. As experienced crews were lost, replacements lacked the depth of training needed to compensate for doctrinal strain. What had once been mitigated by skill now depended more heavily on equipment. In that environment, the T-34's forgiving design, its ability to survive mistakes, became even more valuable. The doctrine failure was not catastrophic in a single moment. It unfolded gradually, engagement by engagement. German units adapted locally, but the overall framework lost coherence. Doctrine that required consistent success at the tactical level could not survive persistent friction imposed by an enemy design that resisted clean solutions. By the time German planners recognized the need for fundamental change, the strategic situation constrained options. Heavy tanks, more powerful guns, and redesigned ammunition addressed some problems but created others. Reduced mobility, increased maintenance, greater fuel consumption. Each solution carried trade-offs that further strained an already overstretched system. The T-34 did not defeat German doctrine by being perfect. It defeated it by being sufficiently resilient at scale. It introduced enough uncertainty, enough delay, and enough cost to make established methods unreliable. Doctrine built on certainty cannot thrive in an environment dominated by probability. In this sense, sloped armor was not just a technical feature, it was a doctrinal disruptor. It forced German forces to fight a different kind of armored war, one defined less by precision and more by endurance. And endurance, increasingly, was something Germany could not afford. Once it became undeniable that the T-34 represented more than an inconvenience, German command began adapting. But adaptation did not mean recovery. It meant containment, attempts to blunt an advantage that had already reshaped the battlefield. Every response arrived late, cost more than it delivered, and imposed new burdens on a system already under strain. The first adaptations were tactical. German anti-tank crews were instructed to aim for weak points rather than rely on frontal penetration. Side shots, rear shots, turret rings, lower hulls, these became priorities. In theory, this restored lethality. In practice, it demanded conditions rarely available in combat. Achieving flank shots required maneuver, coordination, and time. Against a mobile enemy supported by infantry and artillery, those conditions were increasingly rare. Engagement ranges were shortened deliberately. Anti-tank guns were moved closer to likely avenues of approach to increase penetration probability. This increased vulnerability. Crews were exposed to artillery fire, infantry assault, and counter-battery strikes. Casualties rose. Guns that once dominated open ground became expendable tripwires rather than decisive barriers. German tank crews adapted as well. They closed distance aggressively to improve penetration chances. This negated one of their original advantages, long-range engagement, and forced fights into chaotic, high-risk conditions. Close-range combat increased losses on both sides, but Germany could not afford parity. Every tank lost was harder to replace. Every crew killed reduced institutional memory. Technical adaptation followed. New ammunition types were introduced, including improved armor-piercing rounds. These helped, but only partially. Ammunition improvements could increase penetration at specific ranges and angles, but they could not eliminate the fundamental uncertainty introduced by sloped armor. Penetration tables still depended on ideal conditions. Combat rarely provided them. Heavier guns were deployed. The famous 80mm anti-aircraft gun was pressed into anti-tank service, where it proved effective. But effectiveness came at a price. The gun was large, conspicuous, difficult to move, and resource-intensive. It solved a local problem by creating logistical and tactical vulnerabilities elsewhere. A weapon that required special handling and protection could not be deployed everywhere. Tank design shifted as well. German engineers responded with heavier armor and more powerful guns. This produced formidable machines, but also heavier, slower, more maintenance-intensive ones. Increased weight strained engines, transmissions, and fuel consumption. Reliability suffered. Mobility declined. What solved the penetration problem often worsened operational flexibility. This trade-off was critical. The T-34 achieved survivability through geometry, not mass. German responses achieved penetration through mass, not geometry. The result was asymmetry. Soviet tanks remained relatively mobile and producible in large numbers. German tanks became increasingly specialized and scarce. Production realities magnified this imbalance. German industry struggled under bombing, resource shortages, and fragmented logistics. Complex designs slowed output and increased maintenance demands. The Red Army, meanwhile, simplified production relentlessly. The T-34's design allowed factories to be relocated, production lines to be streamlined, and output to remain high despite catastrophic disruption. Training constraints further limited adaptation. New weapons and tactics required retraining crews and gunners. Training time shrank as losses mounted. Replacement crews entered combat with less preparation. Doctrine that relied on precision and coordination suffered disproportionately under these conditions. The T-34's forgiving design, its ability to survive errors, proved more resilient in an environment of declining training quality. Operational adaptation faced even greater barriers. German commanders attempted to avoid frontal armored engagements altogether, favoring defense in depth and delaying actions. This ceded initiative. The Red Army exploited this by pressing aggressively, forcing engagements on its own terms. Avoidance became retreat. Retreat became collapse in sectors where depth no longer existed. The most telling limitation of German adaptation was scale. Local solutions worked occasionally. They never worked everywhere. For every upgraded gun or heavier tank deployed, there were dozens of sectors still relying on older weapons. The T-34's advantage lay not in being unbeatable, but in being good enough everywhere. German adaptation produced excellence in pockets. Soviet design produced adequacy at scale. This imbalance shaped the remainder of the war. German forces increasingly depended on a shrinking number of elite formations and powerful weapons to stabilize fronts temporarily. These formations became fire brigades, rushed from crisis to crisis. When they failed or simply arrived too late, there was nothing behind them. Adaptation also consumed resources that could not be spared. Heavier tanks required more fuel. More fuel meant more logistics. More logistics meant more vulnerability to interdiction. Each attempted solution cascaded into new problems. The system strained under its own responses. By contrast, the T-34 required relatively little adaptation from the Red Army. Its design aligned naturally with Soviet doctrine, industrial capacity, and strategic goals. It did not require perfect coordination to be effective. It tolerated mistakes. It functioned in harsh terrain. It scaled. German adaptation never reached that level of integration. Responses were reactive rather than systemic. They addressed immediate threats without resolving underlying mismatches between doctrine, design, and reality. This is why adaptation failed to restore balance, not because German engineers or soldiers lacked skill, but because the problem was structural. The T-34 represented a different answer to armored warfare, one that valued survivability, simplicity, and mass over-refinement. German doctrine could counter individual features, but not the philosophy as a whole. By the time adaptation stabilized specific engagement scenarios, the strategic context had shifted irreversibly. The Red Army had grown stronger. German resources had diminished. Even perfect tactical solutions could not compensate for strategic exhaustion. German adaptation slowed defeat. It did not prevent it. The sloped armor of the T-34 continued to impose costs disproportionate to its apparent simplicity. Each bounce, each deflection, each failed penetration echoed beyond the battlefield, draining time, resources, and confidence. The lesson was becoming clear. In a war of attrition, the ability to absorb pressure mattered as much as the ability to deliver it. German adaptation improved delivery. The T-34 ensured absorption. The balance had already tipped. By the middle years of the war, the decisive question was no longer whether German forces could defeat the T-34 in a given engagement. They could, and often did. The decisive question was whether Germany could do so repeatedly, everywhere, and faster than the Soviet Union could replace losses. On that question, the answer was unequivocally no. The T-34's advantage was not brilliance in isolation. It was scalability. And scalability, under conditions of total war, outweighed refinement. The T-34's sloped armor was inseparable from its production logic. Angled plates provided higher effective protection without proportionally increasing weight. This meant the tank could remain mobile, mechanically simpler, and within the limits of mass production. Survivability was achieved through geometry rather than complexity. That distinction mattered enormously once production moved from peacetime assumptions to wartime reality. German responses moved in the opposite direction. Heavier guns and thicker armor restored penetration at the tactical level, but they imposed exponential costs at the operational and industrial levels. Weight increased faster than capability. Engines strained, Transmissions failed. Fuel consumption rose. Maintenance hours multiplied. Each increment of battlefield advantage carried a growing logistical penalty. The Soviet approach inverted this curve. The T-34's sloped armor allowed the Red Army to field a tank that remained effective across a wide range of conditions without demanding exceptional logistics. It could operate on poor fuel. It tolerated rough handling. It functioned in mud, snow, and dust. It did not require pristine roads or extensive maintenance cycles to stay in the fight. These traits were not accidental. They were design requirements driven by expectation of catastrophic conditions. Scalability also meant training resilience. Soviet tank crews were not expected to be elite marksmen operating at long range with perfect coordination. The tank's protection gave crews time to react, to withdraw, to make mistakes without immediate destruction. This mattered as the war progressed and crew experience fluctuated. A design that forgave errors preserved manpower. German tanks increasingly punished errors with catastrophic losses. Numbers amplified everything. When a single T-34 forced a German unit to close distance, maneuver carefully, and expend additional resources, the cost was manageable. When dozens did so simultaneously, the cost multiplied nonlinearly. German doctrine was optimized for efficiency against limited threats. It struggled against saturation. The T-34 was built to saturate. This saturation extended beyond the battlefield. German planners could counter the T-34 in specific sectors with prioritized equipment and elite formations. They could not do so everywhere. The Eastern Front was vast. For every sector reinforced with heavier guns or upgraded tanks, dozens remained reliant on older systems. The T-34 did not need to be unbeatable everywhere. It needed only to be adequate everywhere. Adequacy at scale proved more decisive than excellence in pockets. Industrial realities sealed the imbalance. Soviet factories simplified relentlessly. Design changes were evaluated not by elegance, but by output impact. If a feature slowed production, it was removed or simplified. Sloped armor remained because it delivered disproportionate value. German industry, by contrast, layered complexity in pursuit of performance. Each new variant solved a problem while creating two more downstream. Time favored the Soviet system. Every month that passed increased the Red Army's numerical and experiential base. Every month reduced Germany's ability to respond proportionally. Losses that were painful for the Soviet Union were crippling for Germany. Survivability mattered not because it prevented losses entirely, but because it shaped the exchange rate of loss. Doctrine magnified these industrial dynamics. German doctrine required consistent success at the tactical level to maintain operational momentum. When success became conditional and costly, the doctrine frayed. Soviet doctrine, increasingly pragmatic, absorbed losses in pursuit of operational objectives. The T-34's design aligned with that pragmatism. It was not expected to win elegant duels. It was expected to keep moving forward. The tank's sloped armor contributed directly to this alignment. It reduced the probability of catastrophic loss from the first hit. It forced German units to commit more resources to achieve destruction. It lengthened engagements in ways that favored the side with greater depth and replacement capacity. Each of these effects compounded over time. Attempts to restore parity through technological escalation only widened the gap. Heavier German tanks demanded more fuel and maintenance at a time when both were scarce. Breakdown rates increased. Operational readiness declined. Units arrived at the front with fewer vehicles than authorized. The Red Army, meanwhile, accepted losses as the cost of pressure and replaced them at scale. The advantage also scaled geographically. The Eastern Front's terrain punished complexity. Mud, cold, and distance degraded equipment reliability. The T-34's sloped armor allowed it to maintain protection without excessive weight, preserving mobility in poor conditions. German designs increasingly struggled in the same environments. A tank that is powerful but immobile is not powerful for long. By late war, the asymmetry was complete. German forces possessed tanks that could defeat T-34s head-on under favorable conditions. They lacked the capacity to deploy those tanks in sufficient numbers, keep them operational, and replace them when lost. The Soviet Union possessed tanks that could be lost in large numbers without halting operations. Sloped armor played a quiet but critical role in making that calculus work. This is why the T-34's advantage endured even after German adaptation. The Germans solved the penetration problem in principle. They never solved the scaling problem. Every solution they deployed required resources they no longer had. Every month of combat made the imbalance worse. In the end, doctrine bends toward what can be sustained. The T-34's design was not about winning today's fight at minimum cost. It was about winning the war of accumulation. Sloped armor was one piece of that system, small in appearance, enormous in effect. The battlefield did not reward the most refined design. It rewarded the design that could be built, crewed, fielded, lost, and replaced again and again without breaking the system behind it. Germany's system broke. The Soviet system did not. By the time the war reached its final phase, the consequences of the T-34 were no longer confined to the battlefield. They had reshaped how armies thought about tanks, production, doctrine, and the relationship between design and strategy. The T-34 did not simply survive German guns. It forced a fundamental reevaluation of what mattered in armored warfare, and exposed which systems could endure prolonged industrial war and which could not. The most immediate consequence was doctrinal exhaustion on the German side. German armored doctrine had been built around precision, initiative, and decisive engagements. These principles depended on predictable outcomes. Once the T-34 introduced persistent uncertainty, bounced shots, delayed kills, higher exposure, doctrine lost its reliability. German forces continued to fight skillfully. But skill no longer guaranteed results. When doctrine ceases to deliver expected outcomes, it stops being doctrine and becomes improvisation. This improvisation spread upward. German planners increasingly abandoned the idea of restoring balance through maneuver and began relying on positional defense, heavier weapons, and localized superiority. This shift marked the quiet death of German operational armored warfare. Tanks were no longer tools of decisive maneuver. They became reactive instruments, rushed to crises, and expended to delay the inevitable. The T-34 did not force this shift alone, but it accelerated it decisively. On the Soviet side, the consequences were the opposite. The T-34 validated a design philosophy that prioritized survivability, simplicity, and mass over-refinement. Sloped armor proved that protection could be engineered intelligently rather than expensively. This lesson was absorbed deeply. Soviet armored doctrine evolved to emphasize pressure, continuity, and operational depth. Tanks were not preserved for perfect moments. They were used aggressively, accepted losses, and replaced rapidly. The design allowed that doctrine to function. The industrial consequence was just as important. The T-34 demonstrated that a weapon system's value is inseparable from how easily it can be produced under stress. Sloped armor allowed effective protection without extreme thickness, enabling factories to build tanks faster, lighter, and with fewer strategic materials. As German industry collapsed under bombing and resource shortages, Soviet production surged. This was not coincidence. It was the product of design decisions made years earlier with catastrophic war in mind. Globally, the implications were immediate and lasting. Allied analysts studied captured T-34s closely. They did not copy the tank wholesale, but they absorbed its lessons. Post-war armored design across multiple countries adopted sloped armor as a standard feature. The idea that armor geometry mattered as much as thickness became orthodoxy. Vertical plates, once common, became relics of an earlier era. Equally important was the lesson about error tolerance. The T-34 was not comfortable, it was not elegant, it was not optimized for crew convenience, but it survived mistakes. In modern warfare, where friction is constant and perfection rare, survivability against error became a design priority. Post-war tanks increasingly reflected this principle, balancing crew ergonomics with protection and redundancy. The legacy also extended to training and force structure. Armies began to design doctrine around the expectation that not all crews would be elite, not all engagements ideal. Equipment had to compensate for human limitations rather than assume their absence. The T-34 embodied this reality earlier than most. Its sloped armor gave crews a margin of survival that doctrine alone could not provide. Perhaps the most enduring consequence was strategic. The T-34 demonstrated that wars between industrial powers are decided less by peak performance and more by sustained performance. Germany fielded some of the most powerful tanks of the war. It still lost the armored war because those tanks could not be produced, maintained, and replaced at the rate required. The T-34 did not need to be the best tank. It needed to be good enough, everywhere, all the time. This reframed how success was measured. Instead of asking whether a tank could defeat another tank under ideal conditions, planners began asking whether an army could keep fighting after losses. Sloped armor contributed directly to that resilience by reducing catastrophic losses and stretching manpower and material further. In hindsight, the dismissal of the T-34's design reveals a deeper truth about military innovation. Revolutionary ideas often appear crude because they do not align with existing standards of excellence. German planners judged the T-34 by what it lacked compared to German tanks. Combat judged it by what it endured. Those two perspectives rarely agree in the early stages of change. The T-34's sloped armor did not win battles alone. It did something more consequential. It changed the exchange rate of war. It made each German success costlier, each Soviet loss more tolerable, and each month of fighting tilt the balance further. Over time, that arithmetic became destiny. By 1945, German armored forces were shadows of their former selves, technically formidable in isolation, strategically irrelevant in aggregate. The Red Army, built around designs like the T-34, advanced relentlessly. The difference lay not in courage or intelligence, but in which system could survive its own losses. This is why the T-34 matters beyond World War II. It stands as a case study in how design choices echo across doctrine, industry, and strategy. Sloped armor was not just metal at an angle. It was a declaration of priorities: survival over perfection, scale over elegance, endurance over brilliance. Combat proved those priorities correct. If you want fact-heavy breakdowns of weapons that didn't just win fights, but rewrote how wars are fought, subscribe to WW2 Battles.